Hello, everybody, and welcome to today's presentation, Predictive Analytics for Applications, Real-World Instances, and Common Challenges, brought to you by Logi Analytics. I'd like to introduce you to our presenter, Sriram Parthasarathy is a Chief Product Owner of Logi Predict, a new product in Logi Analytics platform. He works with customers to embed predictive insights directly into the applications that business users use on a daily basis. Sriram has over 20 years of experience in designing enterprise and OEM analytical products.
Awesome. Thank you, Billy. Thank you, everyone, for joining the call today. My goal today is it's a 5-step process. For those who may not be familiar with predictive, I'll briefly talk about why this is getting importance and the kind of attention it has, and then quickly walk you through the predictive process. And then, so one thing that we have done is in the last 2 years, we had spoken to more than 150 customers, and we have worked on a number of customer applications. So I'll summarize some of the top customer applications that are very popular we have worked with. I'll give you some insight into what kind of applications customers are building with predictive tools. And then whenever you start a predictive project, there are a number of common challenges. Some are technical, some are business oriented. So I will pick the top 5 challenges we have seen some of the customers we work with that typically face, and what kind of actions we have taken to solve some of those challenges. And lastly, to get a sense of what we can do with the predictive technologies, I've picked up a customer demo that would give you a good summary of what we learned today, the important technical and business concept we learned, and that demo will start from the beginning to starting with the data, to creating a model, and finally distributing the information to the end customer and take some action based on whatever prediction outcomes we have predicted. With that said, feel free to post your questions in the Q&A section. If the question is relevant, I would answer the question during my presentation. If not, we definitely will go through a lot more questions at the end of the Q&A section. With that said, why predictive? If you look at most companies, they typically treat their data as a business asset. So what that means is they are looking for ways to monetize their data. In addition to that, you would see that users are getting sophisticated and they are demanding context-sensitive information of figuring out what should I do based on what scenario could happen. So if we look at most applications out there, they typically talk about what happened in the past, and what customers are looking for is tell me what is going to happen, and more importantly, tell me what action I can take to prevent bad things from happening and for good things to happen. That's essentially the Holy Grail of predictive is predict what is going to happen and act upon it to make good things happen. Having said that, the common example, almost every customer we work with typically have is customer churn, where they normally in the existing application, they tell you how many customers churn in the last month or last quarter. So what they are looking to do is tell me how many customers or who will churn in the next 3 weeks or next 3 months. That way, they can engage with them early and prevent some of those customers from churning. A good example of that is we are working with a customer where it's a $50 million ARR customer, and they are having a churn of $3 million. That is 6% churn. Their goal is reduce the churn by 1%, which is $500,000. That is the amount of churn they want to reduce every year. That way they can prevent the revenue loss on an annual basis. there's a clear definition of ROI, which is an important things to consider, where you want whatever problem you're trying to solve, it needs to have a clear return of investment. That way, it's easy to invest and easy to measure what is the outcome of that investment. Having said that, let's talk about what the predictive analytics process is. This will give you some summary of the number of developers that typically when they look at predictive, how is it different than the traditional programming. So I will give you some insight to the key differences. If you look at the traditional programming, I'm a coder. I used to code quite a bit of applications. What typically do is they write a code in Java or C++ or whatever language of choice onto the data to create whatever outcome you are trying to create. That is the output, right? That is what traditional programming works. The difference in machine learning is you are not writing any code. You are passing the input data, and you are passing what the outcome of the data could be, and then machine learning is actually understanding the input and the output and actually creating all the rules to figure out what the output could be. In essence, the key breakthrough in machine learning is a developer is not writing any code but the machine learning is looking at the input and looking at what the output is and creating the appropriate rules for it. The cool thing with it is, in the case of traditional programming, every time you have to change something, the developer has to go back and code that in. In the case of machine learning, you have to rerun the same algorithm with the new data. It will automatically learn what new things have changed in your data and automatically update the logic. A good example of that is, let's say you take all your 6 months data, take your demographics and invoices, information about which customer paid and which customer paid late, which customer did not pay late. We feed that to the algorithm. What it will create is a late payment prediction model where it can take future data and predict in the future which customer will potentially pay late on their invoices. Similarly, you can take your demographics and transactions data of all the customers in the recent past, and then information about which of those customers churned, which of those customers did not churn. Pass that to the algorithm, and it will predict who will churn and who will not churn in the future. That is the power of machine learning, where it automatically self-trains what the outcome could be, and then learns the appropriate rules to take it from there. Having said that, what is the process you normally follow? It's a simple 3-step process. Let's take the example of customer churn. How do you go through the process of creating a customer churn predictive model? The very first thing you should do is get the historical data. It could be the last 3 months data, or the last 6 months data, or the last 1 year data, where you have samples of customers who have churned and their demographics and their transaction, as well as samples of customers who did not churn with their transaction and their demographics. So you feed the data to the algorithm so that it can learn to predict who will churn and who will not churn. That is the first step of the predictive model, training the algorithm with the historical data. The second step is, I've learned we have a very good predictive model with a good accuracy that can predict a future outcome. Then I want to apply that predictive model onto new data and predict which customer will churn and which customer will not churn. And typically, most customers write the predictions to a database, but it can also be done typically real time. This is the most important part of the predictive insights, where it's important to take the prediction and distribute the information to the right people for them to take some clear action. One thing you will see in the demo I will give later this afternoon is how do you take the predictions in the demo and distribute that to the CEO, then to the loan officer, and finally to the call center representative to illustrate how the same information can be shared with the right context to the right people for them to take some action based on the information that is given to them. That's the important part of Predictive Insight. And the cool thing with the predictive model is it's a breathing model in the sense customers always get new data, maybe every day or maybe once a week or maybe once a month. You can feed the data in back to the model to retrain the model on a weekly or a monthly basis. So the great thing about this is over time your model gets smarter and smarter and smarter. And we have also seen what customers do is they may start with a simple model with a reasonable accuracy. Every month, not only they retrain the model, they may bring in additional data. For example, one of the customers initially they did not include weather data. The second version they may add the weather data. The third version they wanted to use the social media, Facebook data to make the model better and better and better. So the reason I point that out is you don't have to wait for everything to get aligned. That never is going to happen. You make a start, create a model, make sure you get a reasonable accuracy, and then start improving over a period of time. With that said,
hey, Ram, real quick, the audience and I can only see the intro slide right now.
Oh, really?
Yes. There we go. I see the poll question right now. Thank you. Thank you so much.
Should I flip through the slides just to be get it?
Yeah.
Okay.
We see it all right now.
Okay, I'm going to quickly, since many missed the slides, I'll quickly flip through so that people get it. I won't talk much. We talked about different use cases for how somebody people want to know what is going to happen. We talked about the customer churn use case, where you can not only want to know what happened, but they actually want to know who's going to churn and take some clear action. And then we talked about the traditional programming, and we also talked about information about the difference between traditional programming and machine learning, where you feed in the input and the output data, and it outputs the program. And then we talked about two examples. The first example is feeding in demographics data with the information about who paid late and who did not pay late to create the late payment. And we talked about the transactions model. And then lastly, we talked about the process, where we feed in the 6 months data to create the historical data to create the model. And then we talked about the information about creating the actual predictions. And lastly, we talked about writing the prediction to a database, and how the whole process is going to be an automated to constantly feed in new data and go from there. So hope, sorry that the slide was not coming through. Hope that gave you some information about what we covered. Having said that, this may be a good time to do the poll, Billy.
Here's the first poll question. I'll give it a few more seconds for those last couple responses. And here are the results.
Looks like more than 50% of the customers have this in the roadmap. That is a good thing, and looks like a number of them, their customers have asked for it, which is again a good thing. So I think for those who have it in the roadmap or the customers asking for it, I think the next section will be very, very useful, where I would cover what kind of applications that we can build with the predictive tools. So there are in the research we did, talking to more than 150 customers, there are more than 30 different applications we have seen, application types we have seen customers build. But I'm going to cover the top 4 categories that we have seen almost every customer get excited about. That will give you some idea of what you can do from for predictive stuff. The first is this is the number one use case almost every customer want to do, which is they want to predict an outcome. Mostly it's a binary outcome, like yes or no question. Will this customer churn? If the customer is churning, what will I do? If the customer is not churning, what will I do? Or will this loan default? Or will this customer buy the product? Or things like will this customer click on a link? Or will this machine break down? Predictive maintenance, will this machine break down in the next 2 weeks? In all these questions, there is a positive outcome and there is a negative outcome. If there is a positive outcome prediction, you are figuring out what action would the end user you want your end user to take. If it is a negative outcome, your question is what action do you want your end user to take? And then typically for these scenarios, if you were to write code as a data scientist, if you may want to write code using random forest or GBM or GLM. We'll cover some of those things later today. It's a very, very common use case we have seen number of customers do. The second one is what is called forecasting, where we are predicting a numerical outcome. In this case, we are predicting how many customers would call my call center this week, and how many customers would show up in my restaurant. If it is more than 50, I may need to hire more people to staff in my restaurant. If it's less than 50, I'm okay. Or how many sales orders am I getting, or how long will it take for me to fix this job? Here you are predicting a number, could be 50, could be 30, could be 12, some number you are predicting. Based on the number, you are taking different actions. So that's a good, another very good use case of using predictive analytics to do things. One interesting thing is you don't have to do one or the other. You can do a combination. For example, we are working with a pet grooming shop. The interesting use case is they want to predict how many pets would show up to my shop this weekend. That is the first question. The second question is, the first question is a forecasting model, because you are predicting a number. Will it be 50 pets? Will it be 40 pets? And the second question is, how many will not show up? That is a classification question. Will this pet show up or will not show up? In other words, you can create multiple models, each models talking to each other to give you an insight of what is going to happen. In this case, how many people are going to come, and which of those people will potentially cancel at the last minute. You're doing two predictions. Both are very useful to run your business. Again, in this case, the algorithms I would use is, again, random forest, GBM, even deep learning are all good algorithms to use for predicting numerical value. The first two we talked about, classification and forecasting. It is very common across the industry, across our customer base. The next two, it's not common across the industry, but very popular with financial, retail, and insurance customers. In this one, anomaly detection, the couple of examples that will be useful to talk about is one is fraudulent transaction. For example, $1,000 spent on books is okay. $1,000 spent on electronics is okay, but $1,000 spent on books is probably not okay. That's based on category. We can also include time and location. For example, $100 spent on facials in this location at this time is okay, but the same $100 spent on facials at a different location at an odd time is not okay. So we can use a combination of product, location and time to identify the outliers, which is a very common use case we have seen customers do with outliers. Another interesting one is what we call the multivariate outliers, where, for example, we are working with ethanol shop, where temperature by itself is okay, pressure by itself is okay, but the combination of temperature and pressure is not okay. So that kind of combination filters to drive anomalies is a very interesting thing. All these things customers tend to want to do real-time prediction to be able to figure out what action would they take to prevent that from happening. The last one is what we call clustering, where you're grouping customers into multiple buckets. This one is high value, low value customers, high risk, low risk customers. You typically group them into multiple groups. Interestingly, this is the first thing almost every customers do, where they take all the data columns, group them into, so let's say, hey, take all my data, put them in 3 clusters, and see what kind of clusters it comes up with. So one of the examples I typically give is we worked with a telecom customer where we took all their data and then to create 3 different clusters. The first cluster that came back is a cluster where all the customers in the cluster are typically young people who are happy customers, who typically are on a month-to-month contract, but they tend to churn within 3 to 6 months. So the key action that we determine for those customers is maybe give them a good discount, or maybe give them a gift card to allow them to sign up for annual contract, which is something many may have seen it, where taking a cluster of customers, once we identify the demographics and the action to take, we can do a promotion for these are the customers who are potentially happy, but they tend to leave early. So let's see if they can move from the monthly contract to annual contract and things like that. It's a very common use case for clustering. Having said that, a good summary would be, if you are one of those folks trying to take some action to create predictive analytics in the next 2 to 6 months, it'll be good to pick, recommend you to pick one of these scenarios, like predict an outcome. Things like will this customer churn, or predicting a numerical value, how many calls am I going to get into my call center. Or you can also pick anomaly like fraudulent transaction, or even incorrect invoices. Incorrect invoices is very interesting, where almost every company has invoices. So it could be the average is $1,000. Suddenly this month I get $10,000 because somebody made a typo and by mistake added an extra 0. Those kind of things we can definitely predict and then take action. Or it could be grouping customers, right? So you could pick one of those scenarios in one of these buckets, and that is a good action to take and get talk to your management to get buy-in to move on with the project. I'll talk more about that in the next section. With that said, before I jump onto the demo, the identified the top 5 challenges we have seen by talking to hundreds of customers. These top 5 are the ones we have seen many customers face when they are looking to deal with predictive analytics project. The very first one is what I call the real problem. So you shouldn't do something predictive just because it is a cool thing to do. There should be a very strong business value attached to it. For example, the 2 common things that we typically recommend customers do is there any one bucket is are you losing money? Let's predict some factors to prevent you from losing money. Or the bucket could be figure out a way to make more money, right? In the case of a losing money bucket, it could be predicting who will churn, or predicting which customers would pay their invoice late. Those are all the areas where you have some problems. Predictive analytics can do something to prevent those problems. That's a very good use case to act upon. The second one is in the case of buckets to make money. Things like will this customer buy this product, or will this customer click on the link, or will this customer upsell and buy this new service? In other words, for you to get the needed backing and investment from the management, clearly articulating the problem you are solving, and then figuring out a way to articulate a result. For example, by spending this much money to predict who will churn within the next, if you look at the churn example we talked about, we are losing $3 million in churn revenue every year, and our goal is to reduce that by 500K in 1 year. That is timely return of investment with a clear metrics to track of every year. So picking a project with a clear goal and a clear way to measure that goal is a very good way to get buy-in from the management to invest on your project. The second one that we have seen that very common issue with customer base is most customers do not have data scientists in their staff, and they are also not easy to find. They are also on the expensive side, and then so they struggle. We have struggled doing data science project because to be able to do that, you got to know R programming or Python programming and things like that. So this is where what we have seen customers tend to do is they were very dedicated and motivated application teams. They are existing application teams. They know a lot about their existing application. They know a lot about their customers, know a lot about developing software to take it to production, right? So what customer that context of developing to and adding the existing application is a very unique insight your current existing application team normally has. So what companies are looking to do is are there tools I can use to empower these application engineers so that they can use a wizard-driven tool to create the predictive insight so that I can take that insight and plug that into my application. The reason why that is very interesting for them is it motivates by enabling the application engineers in your existing team to do these things. It motivates them, make them loyal to the company. More importantly, they already know what application to build, how to build, and take that to production. So they're able to use these automated tools to create the prediction and quickly plug that in to the application and take it to production. The time to market is extremely important in that process. Plus, they have a full insight into the database, the data tables and things like that. They can actually quickly use a automated tool to create those insights. The next one is this is very, very good. Even if you figure out a way to create the predictive insight, unless the right people have it, nothing typically happens. For example, once you create the insight, the next question to ask is, who do I need to distribute this to? How do I share that with the CEO? What action will he take? How do I share that with the call center person? What action would he take? The important thing is what most customers tend to do is once they create the prediction, they take the prediction, the application these power users and end users use every day. They want to take this insight, embed that into that application. That way, it becomes a natural thing they do every day. They see what is going to happen. They automatically recommend some actions to take within their application to make them automate the whole process in a very, very uniform way. That is the cool power of predictive. Is I remember the acronym PDA: predict, distribute, and act. So important part is the easiest part is to the prediction. Once the prediction is done, it won't have any impact unless you distribute the information within the context of the application the people are using and enable them to act upon inside the application they are currently doing. And finally, last but one is automate the process. You get new data every day. It's important to constantly update the data to make the model better and better and better. For example, you may have customer churn. You did a campaign that improved the process, and customer churn is decreasing, which means the customer behavior has changed. You have to get the new data, retrain the model to change the model based on the changing customer demographics, right? The cool thing with this is what customers are trying to do is automate the whole process every day, every month at this particular time. They want automatically trigger to get the new data, automatically to retrain, automatically to examine is the new model better than the old model? If yes, automatically test it, automatically deploy it. So the whole process of maintaining the whole thing is a very, very important part of predictive analytics, which is something that is important choice when creating these kind of applications. And the last one is time to market. There's a lot of urgency for the customers to deploy predictive analytics to the market. So on one extreme is where you already have an existing model and you want to constantly add new features to it. That is what the customers are demanding. On the other extreme, you also have a lot more predictive questions that you want to answer to be able to deal with the customer demand, right? If you look at the management, what they're looking for is they want all the new things to happen. They want you to do a million things with the least amount of resources and deliver a high quality application on time. I'm sure many of us on the developer side have faced that problem. This is where choosing the right tool helps you not only automate the process of creating the prediction and deploying it, but more importantly, instead of answering one question every month, you could potentially handle 3 or 4 predictive questions over time. With that said, if you look at what we have seen so far, we got a good background for what kind of predictive analytics means, what kind of apps we can build with it. The demo I'm going to show you is to bring the whole thing together. The demo is based on a real use case where my goal is to predict who will default on the loan. I'm going to use the last 6 months data to learn to predict who will default, and then I will take that to apply it on a new model, and then quickly go on from there. I may just use an existing data set to show all that. And finally, my key goal is to how do you distribute the information to run your business. I'll start. So this is what this is a tool that we have launched to the market. I'll give you a quick summary of what we can do. So I'm going to pick one of the models I've already created to save some time. If you notice in this data set, I have typically this is a common thing you would see with most data sets. You typically have 3 kinds of information. The first kind is customer demographics. In this case, I have age, gender, and things like that, and some customer transactions. The different what was the loan, how much they pay, how much they did not pay, and the most important one is whether they defaulted on the loan or not. That is what the column I'm trying to use to predict. That is the column I'm trying to learn to predict. One common question we get from customers is, hey, which columns? If you look at most customer scenarios, they have anywhere from 30 to 200 columns. The first question they ask is, which are the columns that are predictive in nature? So what we tend to do is we typically tag the top 5, the top 10 columns you can use to predict your question. More importantly, when customers see these things, I was talking to a banking CEO last week. His immediate reaction was, if these top 5 metrics are the most important for my business, why don't I simplify my current dashboard to focus on these top 4 instead of the 40 metrics I currently show? That's a good way to think about this problem. And we also notice that data cleaning is a very important part of the puzzle, where it's important that your tool to automate the process of data cleaning, so that things like duplicate rows, incorrect rows, missing values, and even things like age and date of birth are similar. So we keep one, and the other correlated columns we can automatically remove. In this case, the model given accuracy of 80%. What that means is I can try this with different algorithms. 80% of the time, I can predict who will default on the loan correctly. So once I figure that out, I can predict that on new customers. I have around 300 new customers. These customers, I do not know which of them. I only have the data. I do not know how many of them will pay or how many of them will not pay their loan. My goal is to predict of who will not pay and write that to a database, and then the column where I'm doing the prediction is this particular column. Essentially, once I do that, in my database, I have the predictions for which customer, for example, out of 300 customers, the first customers will pay, second one will not pay, the next few will pay, right? In other words, you would not only, so if you look at the whole thing, what I just showed you, I've used historical data to predict who will default on the loan, and applied that on 300 customers, and then predicted who will default. My next step is what do I do with the information? That is where it's very, very important. We talked about what is called predict, distribute, and act. I'm going to show you a very simple use of banking application we have built, where what would the CEO do with the information? What action would he take? What would the loan officer do with the information? What would he take? And what would the call center agent would do with the information? What would he take? Which is a similar set of questions you as a developer would ask to see what this information is useful to take action, right? The first one is I'm going to log on as a CEO, and he sees that yeah, I have $70 million worth of loans at risk, out of which 15 of those customers are first-time defaulters. Maybe as a CEO, the action I'm going to take is I'm going to let my loan officer know, hey, loan officer, please take care of the first-time defaulters. Great. That's a clear action. As a CEO, I'm providing to my loan officer. Great. Well, first part is done. The second part is I'm the loan officer. I come in. I'm opening up my application. I normally use on a day-to-day basis to predict who will churn or who will not churn, right? So I see a message from the CEO. I click. This tells me that he wants me to focus on the first-time defaulters. Great. That is what my today's focus is going to be. I'm going to pick my last prediction. We can, and then I'm going to pick who will default. If you notice, there are 37 defaulters. Many owe between $80,000 to $200,000 range. Many are single. Interestingly, many have a university degree, which means they've already spent a lot of money to get a university education. They no longer have money to pay the second loan. In that context, this is a customer I want to focus on. Then when this customer makes a phone call to the call center, I want make sure we find out what is going on. Maybe he lost his job. Maybe he has a new kid, so he has more expenses. More importantly, let the finance team know not to send this customer to the collection agency because we are working with this customer, right? Lastly, when this customer calls the call center, we can engage with them to say, hey, this customer will potentially default, customer 29155, find out whether he lost his job, what is the new change that is preventing him from defaulting. If you look at the whole system, we walked from taking the data set, learning how to predict. We predicted on 300 customers. Once we did the prediction, we showed you how the information can be distributed to your end customer. What will the CEO do? What action would he take? What the loan officer would do? What action would he take? What the call center guy do? What action would he take? That's a key part of predictive analytics, is predicting what is going to happen, and also recommending what action to take. In that context, I wanted to keep in mind that it doesn't have to be one model. One model could be to predict who will default or who will churn and things like that. The second model could be to predict what is the best time to call them, what is the best action to take. In other words, what we are seeing is customers using multiple models to run the entire business to make it a very intelligent enterprise. Having said that, I'll quickly summarize and then we can take questions from there. So as a developer trying to start predictive analytics, I would recommend to start with one of those four scenarios. Maybe you want to predict an outcome like customer churn, or maybe you want to predict a numerical value like how many customers would call my call center, or it could be grouping customers, or it could be identifying anomalies like fraudulent transactions. So in all of these things, by empowering the application team with the right set of tool sets so that they are able to not only create the prediction, embed the prediction into your application and allowing them to take action within the application is going to make it easy for you to take it to the market the fastest rate. So I would also recommend you guys not to wait for everything to align. Most times that's not going to happen. Get started, slowly iterate with whatever insight you get, and over time it will get better and better and better. So the key action you could take is maybe you have 2 to 3 months, close to 3 months before the end of the year. Maybe pick a question. That is a question you can potentially go beta before the end of this year. With that said, so if you guys want to play with the product, definitely go and click on that link to play with it. And if not, I'll pass it on to Billy for any Q&A.
Awesome. Are we ready for the questions?
Yep.
Great. Our first question is, what if we do not have the data for the question we want to answer?
That is a great question. We have seen that with many customers. The question they want to ask may not meet the data they currently have. So what we typically work with the customer is we do generate we generate the data, create a simple application that they can go take it to their customers to get feedback. Once the customers like what they see and see that that is going to give them value, they always provide the data in the future. So in other words, to start with, it's good to start with the data you have, but if you have a very compelling idea, and even if you don't have the data, by showing that a prototype to the end customer, they will believe in it, and then they'll probably share the data over time. That should not be a problem.
Awesome. Our next question is, are customers adding predictive features to the existing app or as an additional module?
Another great question. We see a combination of both. So so for some customers, we started with, hey, I have an existing application. I want to add Predictive Inside into the application. They tend to start with that. In that process, they do a lot of learning, and then they get more ideas. Then they figure out out of these 10 ideas I've generated, these 3, I will add that to my existing app. These 7, I could be creating a brand new add-on module that I may want to launch later this year. That's typically what we have seen customers do. Start with adding to the existing app, but once they learn new things, they tend to navigate to adding a brand new module that they want to eventually sell that to their customers.
Great. Looks like we have one more question in. Audience, if you have any questions, please post them in the questions panel for us to answer. This question is, do you have any guidance on how long it takes to build out a predictive application end-to-end?
That is another great question. We have seen once you identify the question that you want to answer, and then identify the data set, typically the process is you would take that, create the prediction, and put up a simple prototype to figure out how to distribute the information to the end user, and identify what actions do they want to take based on positive outcomes and based on negative outcomes. Once you build the prototype, that typically takes anywhere from 1 to 3 months. After that, the key part is sharing that to the end users and getting feedback and reiterating the process. So 1 to 3 months is to time to create the beta application, and then getting feedback to the end user from the end customers to tweak it and make it better is what the approach I would recommend the customers, everyone to follow.
Great. And we do have one more poll for the audience that I will launch right now. The question is, are you interested in a customized demo of Logi Predict? Give it a few more seconds for those last few responses. And here are the results. So, Sharam, is there anything you would like to add before I close things out?
This is great. Do we have any other questions? Any time for more questions? We are too close to time.
Let's see if we had any more come in. We actually just have one come in right now. Question is, can you tell us more about the algorithms used in the software?
Okay. A great question. We do have a number of algorithms in the software, the one I showed you. Typically in machine learning, for linear problems, you tend to use GLM or logistical regression. That's more customers tend to know and relate to and start with. But in reality, all the problems are non-linear in nature. So that you tend to want to use non-linear algorithms like a random forest and GBM and expose and things like that. Those are all the algorithms in the demo we support out of the box. So the good thing is, as new algorithms comes in, it'll automatically those will automatically show up there. That way, you as a developer using an automated tool like that will be able to focus on solving the problem instead of focusing on what algorithm to use and how the algorithm works and things like that.
Awesome. Okay, we have one more question. The question is, if an application is having the predictive accuracy of 80%, what about the remaining 20% error, and how is it affected based on the field?
That's another good question. Generally, the accuracy is very dependent on the industry. If you take a look at healthcare, they tend to want to have accuracy of above 90 to 95%. You want to use the predictive model, but in general, for marketing and sales use cases, we have seen customers start with 55 to 60% is a good way to start with. And over time, they add, remove columns to tweak and make the accuracy better. Having said that, 80% means 80% of the time you can predict if somebody is going to churn or not. You will eventually lose those 20%, which means it's very difficult to get 100% accuracy. There will always be some you would not be able to predict, and some you would actually even incorrectly predict. So you may predict somebody is going to churn, even though they may not churn. So I think that decision, what to do and what not to do based on the errors, is something is very specific to the use case, the business use case. In the case of marketing, that is not a big deal, but in the case of healthcare, that is a big deal because you are trying to predict will this customer need treatment or not. So that is why higher accuracy is meant for healthcare compared to the typical marketing use cases.
Awesome. Well, Sharon, I would like to thank you for a great presentation today. I'd also like to thank today's sponsor, Logi Analytics, for providing the DZone audience with a great webinar presentation. And lastly, thank you to everyone who showed up today. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.
Thank you, Billy. Thank you, everyone.